Hi, Mukerem. Can you hear me?
Yes, hi, sir. How are you?
I'm doing great. So, yes, just to make a introduction, my name is Ibsa Abraham, and I'm head of education at HSP at us2. And so today we are going to be having a competition for the third round, third place. And congratulations, Mukerem, for making it this far. This is a huge accomplishment. And we are going to be focusing on data structures and algorithms today as well. But before going into the problem, can you introduce yourself?
Okay, I'm Mukerem Ali. I graduated from AS2 Adama in computer science and engineering, and my dual degree also in communication and electronics engineering. And my master's is specialized in data science. Now I am Group 48 remote education in HSCV. That's all about my background.
Nice. Okay, so I'm going to be sharing a SharePoint link with you on the chat. Did you get the link?
Yes, can you screen my screen?
Okay, yes. Okay, so the problem statement that we have for today is you are given numbers like this. Let's say 1, 2, 3, 1. So these are the numbers that we are given, and we want to make our arrays palindrome. In this case, if we look at the first number and the last number, palindrome means when all the elements can be read backwards and forward in the same way. So when we look at the first one and this one, we know that these two numbers are palindrome. But when we come into the left, then these two pointers and they are not a palindrome. So what we can do to make this number palindrome is we can potentially merge these two numbers and take their sum. So what we can do is we can have something like 1, and then if we merge these two numbers, what we are going to have is
5
1 and 1. And now our total, so the number of the operation that we did is 1. We only merged these two numbers in order to convert our arrays into a palindrome. So our operation is 1. And so the question is, given this kind of arrays, return the minimum number of merge operations that you have to do in order to convert the array into a palindrome.
Okay. My question is, 2 and 3 are consecutive numbers. What if they are not a consecutive numbers?
Okay. What do you mean by being a consecutive number?
For example, the first number is 1 and the last number is 10. How can we merge 1 and 10? Because they are in different positions and they are not consecutive. So we can make 11 both of them, or what should I do?
Okay, so in this specific example, what we can do is we see like 1 and 10, and they are not palindrome, right? So
yes.
we want to try to make them as palindrome, and sometimes you can have an operation like this, like 1, 2, 3. And for example, in this number, like there is no way to make them palindrome, right? Because like if you have 1 and 10, so in order to make them a palindrome, you have to make like the elements on the both side equal 1 and 10. But it's not possible to do that. So you come to this point and then add this into the first one, and that's going to be 3. And then you will try to add the last one. It's not possible. And finally, what you are going to have is just one integer, in this case 16, and which is palindrome by itself. So the number of the operation that we did for this one is we merged this two, and then this. So we did three operations in order to
okay, so the merger should be for the consecutive elements only.
Yes.
Okay. So, should I start from anywhere to merge?
What do you mean by starting from anywhere?
For example, I can start 1 and 2, or I can also merge 3 and 10. We have both two possible options, so it's not
Yes.
mandatory to start from the left.
Yes, the way that makes sense for you, you can start from anywhere.
Okay. Okay, what's the constraint?
So for this one, we can expect the size of the nums to be 10 to the power of 5, and the value could also be up to 10 to the power of 5 as well.
Okay, okay. The numbers, they are all positive, or is there negative numbers?
That's a good question. So we have all positive numbers.
Okay. Okay, for example, the first example is 1, 2, 3, and 10. So in this case, I check the both in this 1 and 10, they are not equal. So I should merge either of them, either 1 with 2 or 10 with 3. But the possible solution should be, it's a better, or the optimal solution should be, I should merge the minimum number, because I can get number 10. It's possible to get a number 10 by merging or summing some numbers in the left, but it's not possible to get 1 by adding any positive numbers with 10. So the possible solution should be adding or merging with the smallest among the both sides. So I have a left and right. The left should be 0 and the right should be n-1. So if both are the same, I should I use 2 pointers, so I should increment the left by 1 and decrement by right by 1. So I move both them. But if they are not equal, I should merge either of them. So in this case, first I check what is the smallest number. If the left number is the smallest number, then I should merge that number with the next left number. But the right number is the minimum among both, so I should merge that number. That makes sense?
Yeah, yes.
Okay. So for example, left is equal to 0 and R is equal to 3. So they are not equal. The next one. Okay. I use the same array, so I will not use another array, but because I want to use implement with constant space complexity. So the remaining numbers are storing on the same array, but I use the pointers. So this number would be 3 and this number would be 10. So the right should be in the same place, 1 and 3. I check the left and the right, 3 and 10, they are not equal. So I should merge either of them. The minimum number is this. the next array should be 1, 3, 6, and 10. I count also the merge. I use a counter variable to count the merges, and it's also 3. The while loop should be up to left and right, while left less than right. If both pointers are on the same pointer or on the same index, the loop or the iteration should be over. So the L should be not 1, it's 2. The second and the third elements also they are not equal, so I should merge the left. So the next array should be 1, 3, 16, and 10. The L should be 3, R should be 3. Yeah, but both elements are the same, so I finished the merging process. So it takes around 3 steps to get the palindrome. That makes sense?
Yes, the idea makes sense, but how do you count? Like in this case, how do you know whether you are making the operations or not? So
Okay.
when do you count?
Okay. In every iteration, there are 2 possible ways. If they are not, they are equal, I change both L and R, the right pointer, by 1, make shift both of them. In this case, there is no merging, so there is no adding a count on the merging variable. Otherwise, the second possible option is they are not equal. It should be 1 merge, either in the left or in the right. So we add the number 1 to the counter, and I also shift either of the pointer, either left or the right. Yeah, that's my approach.
Yes, maybe we can test this one more example, this one, and then
Okay.
we can put
Okay.
it to implementation.
It's possible. Okay, in this case, L should be 0, and R should be initially 1, 2, 3, 4, 6, 7. So R should be 6. So the left element is greater than, so I should merge the left and the right. The right value 1, so 1 should be added with the 3. It makes 4. So the right should be decreased by 1. So the counter also 1. Initially, the counter is equal to 0. Then the next element is this 4 and this 4 are equal. So in this case, I move both the left and the right by 1. So the left should be 1 and the right should be 4. The counter is the same because in this case, I didn't merge any variable. So the next element is 3 and 2. 3 and 2 are not equal. So I should merge the smallest, that is the right side. So in this case, the right side should be 2 plus 1, it makes 3. This value should be 3. L is equal to 1 and R is equal to 3. The counter should add by 1, 2. So the left element is 3 and the right element is also 3. So both of them are equal. So in that case, I should counter both of them. It's 3 and it's 2, and there is no adding a counter. So they are on the same index. So the loop should be ended. So total number of merging is only 2.
Yes, that seems like it's working. So I think you can proceed to
Okay.
implementation.
Okay. So the time complexity it's O of n because it's a linear time, and there is the space complexity. It's a constant because I only use 3 variables. Okay. Can you give me the function structure?
Yes. A couple of seconds.
Okay.
Okay, you can start writing now.
Okay. Okay, left value should be 0 and right should be n-1 and the merge initially is 0. Okay, next, while L less than R, what should be if nums at index L is equal to, not L, it's left. Okay, it's right also. The left element is equal to nums of right. Then it should be, both of the elements should be moved by 1, and the right should be decreased by 1, else, or alif, nums of left is the smallest, and of right. In this case, nums, in this case, the nums element should be increased by 1. The left value should be increased by 1, and in that value, at the index of nums of left should be the nums of left minus 1, the previous element. So first, I move the left element. That is the indented, or I should add element in the next element because the first element already it's ignored or merged. So first I move the left or the pointer to the right, and I should add in that position with the previous element. So the merge count also increased by 1. Lastly, else, which is the right element is greater than the left element. The right element is less than the left element. In that case also, the right element should be decreased by 1. Nums at the given right element should be nums the previous element. The previous element is right plus 1, and the merge element also increased by 1. Yeah, finally we can merge. That makes sense. But what if both elements are okay? Yeah, that makes sense. Okay, this example. Okay. Minimum operation. So print minimum operation. Okay. List is not defined. Okay. Minimum operations. Okay. It should be minimum operations. Yeah, it's 2. And how about the first element? 1, 2, 3, 10. It takes 3 operations. 1 and 2. Okay. This element should okay, yeah, 3. Okay, the first example, 1, 2, 3, 1, it should be 1. 1, 3, yeah, it's correct. So time complexity is equal to of n space complexity should be of 1. Yeah, that makes sense. Else merge, move the pointer which have the smallest value and merge the index. Or increase the merge count by 1. They are not equal. Iterate until left less than right.
Okay. I guess like we can submit it to the liquid and then see if
Okay.
Okay, I want to share my screen. Okay. Can you see my screen?
Yes.
First solution. Yes. Congratulations,
Okay.
Mukerem. I passed. Okay. Yes. So yeah, I think that is it. And you have implemented the code. If there is anything that you want to add or maybe optimize it, you still have like 8 minutes left. But
Okay.
otherwise, we'll help you.
Okay. I can add some comments on the code, or
No, it's not necessary.
okay.
I think the CD code that you wrote over here is very
Yeah,
descriptive.
it's the optimal way. There is no to more make efficient than the linear time. So that's the best or the optimal approach to solve this solution. And the space is also an optimal space complexity. As that's all about my approach.
Okay, I guess that's it. Thank you for taking the time to interview for this
Okay.
competition, Mukerem, and
Thank
we should.
you. Okay. Thank you.
Okay, welcome, Kenenisa. Yes. Hello. Okay.
Okay. Hello.
Yes, can you hear me?
Yeah, I can hear you.
Your voice a bit low. Maybe if you could try to speak a bit louder, that would be great.
Wait, let me increase the mic's volume. Okay, can you hear me now?
Yes, perfect.
Okay.
Can you? Before getting into the problem, so I want you to introduce yourself. I already did with the previous interview. Who's Kenenisa and from which group are you?
I'm Kenenisa Alamayo, and I'm from Group 47, Remote Education.
Okay, and this is like the third round competition for the third place competition, and I shared you a problem. I shared my link on the chat,
Okay.
and then you have 30 minutes to approach the given problem.
Let me open the SharePad.
Nice.
Okay. Yeah, I can see the SharePad.
It's nice.
Okay.
All right. So the problem that we're going to solve today is, sorry, let me just copy paste the example. It's called merge operations, and we are given numbers, list of integers. And what we want to do is we want to make this list of integers a palindrome. And as you can see from the first example, this is not a palindrome. And
Yeah.
to make them a palindrome, we can merge two consecutive numbers and take their sum. For example, in the first case, we can merge these two numbers and have something like this. And when we do this, this is now a palindrome, and the number of the merge operations that we did is 1. Only did one merge operation, and we converted our original arrays into a palindromic array. So what you are going to be doing is, given this list of integers, you will find the smallest number of operations that you have to do in order to convert the original integer into a palindromic
Okay.
integer. Does the question make sense?
Yeah. What's the constraint on nums and the value of nums?
Okay. For now, we can say the nums could go up to 10 to the power of 5, and the values of nums could also go up to 10 to the power of 5. But
Okay.
I also wanted to see if the size of the numbers could change the number of the operations that you do, how it affects the problem.
Okay. So the so it won't be negative, right? The value of nums.
Yes.
It's only positive. Okay. So 0 is less than or equal. Can it be 0? It can be 0.
No, it can be. It's the smallest one is going to be 1.
Okay. So it's from 1 up to nums of I is going to be less than or equal to 10 to the power of 5, right? And then also its length is going to be 10 to the power of 5. Okay.
Yes.
Okay, so I have some questions on the operations. Is it allowed to merge any two numbers or just two adjacent numbers? How is that going to work?
So adjacent numbers.
Okay, only adjacent numbers.
Yes.
Okay. So I have an example here. If I have some number here, so what if nums is equal to, for example, 3, 2, 2, and 4. What would be the operation on this? Since we would have to merge this, right?
Yes.
Okay. But these two numbers are not it's not possible to merge these two numbers, right?
Yes. So what we can do is we can potentially merge all of them into a single integer, and the single integer can be considered as a palindrome.
Okay. Okay, so we have some numbers, nums, and then we want to create a palindrome, which means it will be centered around some number. And we want to know the minimum operations we have to do. Okay, so I was thinking to start from the middle and then have 2 pointers going outwards. And then we can check if 2 numbers are mergeable or not. But I don't know if that will make the array palindromic or not. Do you know what I'm saying?
Sorry,
So,
what was that?
For example, if you have these numbers, like nums is equal to 1, 3, and 1. If it's an even array, we start from the middle and go left and right. And then if these 2 numbers are not similar, we merge them. So these 2 numbers will be 5. And then we go out to look for other numbers from this and this side, because the middle is already palindromic, so we don't need to check that anymore. We need to check the other numbers. But since we can't merge outside numbers, I don't know how that's going to work. So we have to figure that out. So if we could have done this, which is like if we could have merged these 2 numbers, we can get away with making this a 7, a 2, a 2, and a 7, and this would be a palindrome. But I don't know if that if we can do that. We can't do that, right? Yeah, we can do that. Okay. So our pointers should start from the left side and the right side, right? And then check to see if they are palindromes or not. So how is that going to work? Okay, if both numbers are similar, we just move our pointer to the left and to the right, and then we check these 2 numbers. Okay, so what do we do about these 2 numbers? For example, if we have nums equal to 1, 2, and then some number 5, 6, 3, and 1, we can check the outside 2 numbers, and then after we check 2 and 3, how do we go about merging any of this? Okay, these 2 numbers should be similar to make a palindrome. So what can we do about this? Okay. Okay, so there's something here. Okay. So what other example can you give me besides this example? What other example can you give me?
Let me give you one, for example. We can have something like this as well.
Okay. Okay, this okay, there will always be a solution, right? Because we can merge all of the numbers and make just one number, and that will be palindromic. There will always be a solution. Okay.
That's correct.
Okay. Okay, well, what do we do with this? We start a pointer from here and here. And then if they are not similar, okay. Okay. So just thinking about the brute force solution, what would be the optimal solution here? Like the optimal, just the answer for this
For this
problem.
one?
So we're able to make this guy is a palindrome, right? This is a palindrome, and then this and this number can't be merged, right? So all of these numbers have to be merged to make all of this palindrome, right?
Not actually. We can merge, like for example, we can merge this. We can have 4, and then we can merge these two numbers, and then what we are
Okay,
going to be
to
talking
create.
is for
Okay, okay, okay. That makes sense. Okay, that makes sense. But now we would have a 3, a 2, a 1, and a 2. So for this, we need to look at this and merge these two guys. Okay, that makes sense. Okay. Yeah. So. Yeah. Okay. So what are some edge cases we need to think about? And okay, this is the optimal solution, but if we were to brute force it, it would just be like merging some numbers and trying to see if it's a palindrome, which really doesn't work. So we just need to check for 2 pointers, and then if they are equal, we just move the 2 pointers. If one is greater than the other, we will move along the array until we can find, until we can merge enough numbers to make like the pointer on one side. So what I would do is first I would create 2 pointers. So let's just do a pseudocode kind of thing. So I would have pointer 1 and it's not pointer 1 and pointer 2. This will be at the end of the array, and this will point at the start of the array. And then we can go from the start. If start and end are equal, move pointers. If a start is greater than the greater than end, move end. If start is greater, if end is greater than start, then just move start. And we would have some like running sum here, so we would have some in here to see what numbers we merged. So this would be a good algorithm to solve this problem, I guess. And the time complexity for this would be, since we're moving 2 pointers, and one pointer will be at one element at a time. So that would just be of n time complexity. And for the space, we would just need to store 2 pointers. So that would be of 1 time complexity. No, space complexity. So the space would be of 1, and the time complexity would be linear. So I think that's a good solution. I think I can code that out. Can I move to the code?
Yes.
Okay, so only nums is given, right? N is not given?
And it's not given.
Okay, so I can just get n from nums. And then I would have a left pointer and a right pointer with n minus 1. And I can traverse the array while left is less than right. And I can say if nums of left is equal to nums of right, if both of them are equal, I can just go left I can push the left forward and I can push the right backwards. And else if nums of left is greater than nums of right, I'm supposed to have some running sum, so let me just go down here and say yeah, sum is equal to 0, and then while nums of left is greater than okay. Okay. Nums of left is greater than the running sum. I can just move the right pointer to the left, and then I can add running sum plus equal to nums of right. But I have to add before I move the pointer. Yeah. So nums of right would be that. Okay. Okay, so one other like edge case I need to consider is what if the running sum goes beyond the left sum? So, for example, when we have numbers 1, 2, 3, 4, like 1, 2, 3, 4, and 1, can I take this example?
Okay.
Yeah, I can take this example. So when I see these two numbers, they are the same, right? So I move my pointers to this position. So L would be here, and R would be here. R is greater than L. So when I move my pointer to this, when I add these two numbers, they will create 5, right?
Yes.
So 5 is greater than 4. So now there is, like, I have no option but to merge these two numbers into one. So the only way to make this a palindrome is just to make this like this. I don't think there is any other way.
I agree.
Okay. So we also need to consider that into our example. Okay. So while left is greater than the sum, we just increment, right? So the merging operation, I also need to count the merging operation. So I will have a count here. And on this case, I don't merge anything, so I don't count anything. On this one, I have to count the merge here. And then my left pointer would move. It would be +1. And okay. So here, now, if the running sum, okay, can we track pointers that okay, so on the previous example where 1, 2, 3, 4, and 1, what if there is some number here that can be a palindrome? But we need to match to 4. So it will be 1, and then this guy's merged would be 5, and then there would be a 1, a 1, a 1, and a 4, and a 1. So how would this work? Do I need to replace any numbers?
That's a good question.
So now, after I merge these two numbers, I will get 5, right? So now I can merge 1 and 4 to make a 5. So this will be the solution here. Okay, how do I go about this on my solution? Okay, so if I have
one thing here at this point, like we have when we started out with this example, the first one and the last one is already a palindrome, right? So we are going to be removing them from the list.
Yeah.
So we are now supposed to only work with 2, 3, 1, 1, and the 4.
Yeah.
Maybe like this example might not better reflect. It's because we have 4, 1 here, but it was supposed to be 1, 4.
I just mean like after we jump these two numbers, the 1 and the 1, we would have this, right? So according to my current algorithm, I need to make to merge these two numbers to make this number. But by merging these two numbers, I would make a 5, and then I would have a 4. So the next would be not to merge these two numbers, not to continue to merge these two numbers. It would just be to merge these two numbers.
On the left, from the right side. That makes sense.
Yeah. So I could make a 5, and that would be a palindrome. I think that's a good solution if I'm not. Okay. What do I need to do here? Okay. Okay. So okay. Do I like? I'm trying to see if I have to be merging some things and replacing the array. So if I have to do that, that wouldn't be a good solution, right?
But
because I need
like,
to maintain
you
some
can
array.
continue with what you started, like
Okay. That should be. Let's just continue. Okay. What were you about to say?
yes, like I was saying, if you want to merge them, you can use like the same array to basically merge like the numbers. For example, like as you just started mentioning, when can you give a good example?
What? I can hear you.
Oh, okay. What about now? Like when
Okay.
like just keeping track of the running sum, you are keeping track of the running sum, right? But at some point, the running sum might be greater than numbers that you're comparing against.
Yeah.
So in that case, you can still go ahead and then find and do another merge for the current running sum, right?
Yeah.
Yes.
Yeah. So I know. Oh, okay. So, yeah. So as I was saying here, to compare to like to make two sides of the array the same, I don't just have to consider one side, like merging one side of the array. I can also consider merging the other side of the array, right? So that
yes,
that's also valid, I guess. So okay. Okay, so let's just do this. If running sum is equal to nums of left, right? I can just move my left pointer, and yeah, if it's not, that means the running sum is bigger than the left sum, right? So the right part is bigger than the left part. Okay, so for this I can just do. Okay, I need. First I need nums of left here. I don't need to start from 0. I used to start from nums of left.
One thing that might be
No.
a bit complex here is
What?
if we still like go again and then try to find another merge for the current running sum, we might still like get the same kind of problem. Like the value, let's say the value from the left side might still be greater than after doing this operation here, the value from the left side might still be greater than our current running sum.
Okay.
So this won't guarantee us that we are going to be getting equal numbers at the end.
Yeah. Okay. Okay, that makes sense.
And what if we do this? Is there any way that you can keep track of the answer on the fly? Like when, what was this example? I think it was this one. So here in the first example, yes, so you have 1 and the 1, and then you are obviously moving your left pointer to this one, but you realized according to your solution you have to move a pointer from the left because it's not equals to, it's less than the current one. So now when you come to this point, you have pointer of sum which is 5.
Yeah.
You don't have to find it for 5 again, but you can just assume 5 and 4 are another pointers, and now you will try to do it for 5. Try to make these 2 pointers equal, and you have 4, so you move to the right side, and then you get 5. And then now at this point, the 2 pointers are equal values. So you can move both pointers, the left one into, you increase the left one by 1, decrease the right one by 1. So what I'm saying is you can potentially use the same array to keep track of the running sum and use those to calculate the number of the merge operation value.
Okay, yeah, that makes sense, yes. Yeah, that definitely makes sense. Okay, so like one other thing we can note is that for any palindrome, the left sum and the right sum are equal, right? No, they might not be, because this can be a 1 and this can be a 5, and their left sum and right sum can be okay. Okay, so I need okay. How do I go about this? Okay, where is my pen? I need to consider 2 points, and then I need to move until this guy is less than that. Okay. Okay. So, okay, because this is a left sum, I need to like have it here, and then when they are equal, I'll just move my pointer, and if they are not the same, I'll just make like a running sum for left and right. And then I can just discard that when I find equal items. Okay. I think, okay, but yeah, that should work. Okay, so what I'm thinking is, let's just say we have a left sum and a right sum, which are first equal to 0. If we have the same numbers from left and right, we just ignore them and move our pointers forward, right? So that makes sense. After that, let's just have an else here instead of an else if, to be clear. Okay, so else we can do, okay, where was the list? Okay, so this will be like our left sum would be at okay, this is okay. So our left sum would be nums of left, and our right sum would be nums of right. Okay, so okay. So if our left sum is greater than our right sum, we need to add something on our right sum. So our right sum would be plus equal to nums of right, and my right pointer would move to the left. Else, so I also need to update the counter, but I'm only doing this once, so I'll do it later. If they are equal, we need to do something. So if they are not, we need to do something. Okay. So okay. So we're just trying to make them equal, right? So we can just say while left sum is not equal to the right sum. Yeah. The right sum, we can do this. If it's greater than the right sum, we can do this. If left is greater than the right sum, we can just add the right to the right sum. And then if we just say else, they're not equal. So it would just be left sum plus equal to nums of left. And then left would move to the right. Okay, I think. Okay, so while we're able to make them equal, we can move on. So for each of these operations, we can just update our count. Yeah, I think this works. And then we can just return our count here. Unless there is something I missed. So let me just run it. Let me just dry run it. So
Maybe can we convert them into a function?
oh, okay, into a function.
Yes.
Okay, so def let's just call it run, and then yeah. So okay, I can count if the left sum is okay. So let me just do it with the example I gave above. So it's 1, 2, 3, 1, 1, 4, 1, right? So I start from these, and my left and my right would be 0 and n minus 1. I move the pointers. My left would be 1, my right would be n minus 2. And then these two numbers are not equal. My left sum would be 2, and my right sum would be 4. So because my left sum is less than the right sum, which is which condition was it? This can scroll. Okay, so it's this condition. My left sum is less, so I add 3 to it, so that would be 5. Now my left sum is 5 and my right sum is 4. So until they are equal, we try to merge from the left and from the right. So the next operation would be to merge the numbers on the right. So 4 plus 1 would be 5. So 5 is equal to 5, so we don't need to continue anymore. So our pointer would be pointing at what? That's what I need to figure out. Okay, so we move the pointers after we add them. So my 1 would be pointing at 3 and 1. Okay, so okay, I might not need this. Okay, so for 3 and 1, what would happen? My left pointer would be at 2, and my right pointer would be at n minus 3 or n minus 4. N minus 4. So my left sum would be 3, and my right sum would be 1. And because my left is greater than my right sum, I will add. Okay, this is not making sense because this part is not right. I need to move the pointer and then add instead of adding again, because I haven't moved the pointer here. It would just add again another input. So I need to move this down.
Okay. So Anissa, unfortunately, we have run out of time.
Okay. Okay.
But
I think this works, but yeah, I think this works.
do you think that is this your final solution, or is there anything that you want to do?
I need to find out if the right and the left pointer will stay where they would stay. So after we add these two numbers, I need to add. I need to add right minus 1, not okay. Right minus equal to 1, and this would also be left plus 1. So I need to add the next number to this number to merge them together. I need to go forward. Okay, this works. Yeah, plus equal to 1. Yeah, this works. I
Just
can
read
just
through the example.
remove the numbers. Yeah, I think this works.
Okay, maybe we can we run it through one example and let's see.
Okay, I can print 1, 2, 3, 1, 1, 4, and 1. If there is a syntax error, maybe. Oh, it's printing. I'll run. And let's say we have nums here. It's 6 because we need to do 1 merge, 2 merge, 3 merges. Oh, why is this 6? Okay, so the first merge would be between 2 and 3. I've merged that. I've counted 1. Then the next merge would be between 1 and 4. I will count that. 2. And then the next merge would be between 3 and 1. And then it would be 3. Why is it 6? What?
Let's see. So for the first one, the left and the right pointer is going to be changed, and we have 2, which is different from 4. So
yeah,
since the left sum is less than the right sum, we're going to be increasing the left sum from the left. We add 3, and then we will have 5, and still 5 is different from 4.
Yeah. We add the 2 pointers. I don't understand why this is. Wait, let me just do one. Left sum. Let's see what the left sum and the right sum are. So it's going from 2 and 4. Yeah, I've got 2 and 4. Then it's 5 and 4. Then I've added 1 to it, so it would just go out of the loop, and the next one would be 2, like 3 and 1. But for 3 and 1, it would just be okay. This is the problem. Okay, I'm not checking if left. Oh, it's going out of bounds. That's why. Oh, I'm sorry. Yeah, it's going out of bounds. That's the only expansion.
Okay, maybe like we are counting every single integer that we are adding, but since we are like pairing them together, we might want to decrease the number of operation by 1.
Oh yeah. Okay.
Maybe if it might, for this case, it might work, but here, like you need, I think it is here that you need to arrange your solution like that.
Okay.
Because like if you potentially add these 3 numbers together, the number of the operations that you did is not 3, it is going to be 2. But I think here we are counting it 3 times, right? Or am I mistaken?
No, the number of operations would just be 2, right? So we added this part, and then those merged would be added again. So it would just be 2 operations. That's it. But for this one, I have where was it? I have this, right? This is what's going out of bounds. It's actually adding 1 again, not 3 onto it. So that's what's creating the problem. So if let me just add 1 one condition. So if left is equal to right minus 1, we can just break this. We don't need to check anymore. If the numbers are next to each other, and then if left, okay, if they are equal, we don't need to count. But if they are not equal, so I can just say if nums of left is not equal to nums of right, I can just increment my count and I would be done here. So I think this works. This need to be commas. This should be 3. Oh, timeouts.
Okay, maybe like try to fix it in the next 2 minutes.
Okay.
Yeah.
I can find it. Left is less than right. Okay. So what's timing out here? Let's see what the left sum is, what the right sum is, and what the left and right are. I'm missing something, but I don't know what's okay. It would just be TLE, right? So I don't need to read. Okay. So if left is equal to right minus 1, which means yes, it just means that I have 1 and like I have 2 and 3. So no, this is very hacky. So I don't need to do this, I guess, huh? We can just, okay. So our algorithm is working by adding previous elements to each other and checking if 2 numbers are equal. So I just need, can I scroll? Why can't I scroll? Oh, it crashed. Okay. So I just need another condition here. So else if left is equal to right minus 1. So right minus 1. And here I can just say nums of left is not equal to nums of right. I can just say just count plus equal to 1. There needs to be some condition. Okay, it says 4. So
what was like done? Well, this month was supposed to be 3, right?
yeah.
Okay, what if we do this like maybe we can paste this back. If we just have like this the number of the operations that we did, and here instead of increasing count, we just increase the number of the operations by 1, and then our count is going to be the operations minus 1. So what do you think about this thing? This work?
Okay. So for this, we're counting the number of times we've shifted, right?
Yes. And if the total number of the integers, this is also not working.
Oh, okay. So we don't need minus 1, right? It can just be number of operations. But that would just be like adding to it. Okay.
Add the previous one.
Yeah. I think the solution is correct, but I don't know.
Yes, the idea works, but it's just a bit implementation detail. So I think this is a good time to stop our interview.
Yeah.
Thank you so much.
Thank you.
taking the time to interview, and wish you good luck. team. So regarding like for the third position, it was like a first competition between Mukerem and Kenenisa, and both of them were absolutely great. They had a working solution, but we had to make a decision between the two. So, and the implementation was the Mukerem implementation was clean, and he was able to code it up faster than Kenenisa. But the idea was both of them had a working solution, which involved using 2 pointers. So for that reason, for the implementation reason, Mukerem is the third place winner of the ACL HSB Champions League competition for 2023. So congratulations, Mukerem. And Kenenisa, your performance was also great. So you are the fourth place winner. So congratulations to you as well. Okay, so yeah, that's it. Thank you.